We're going to be looking at the following circuit, and this is part one, more of kind of a part two, but really a part one. Previous video that we have linked in the playlist below the like button is really just getting ourselves familiar with the equipment that we have. Now we're going to actually build a small circuit with LEDs and write some code for it. As always for this class, we're going to be using the STM32F303 nucleo-32 board. The packaging is just going to look like this. This is what it came in. And so we can take this and we're going to put it into our board. We should notice that there are specific writings on each of them. Some are like 5 volts we have here. We have one that's 3v3 volts over here. We have a reference and we have all of these different pinouts. And we're going to look at that more in a second. So we can come over here and just place it snug into our board. And just pushing it down, making sure it is firmly in place, but also not hard enough to break anything. Now, what we're going to want to do is first we can wire our push button. So we are going to take our little button. I'm going to put it super far, and notice kind of the markings right here. The actual, I like to think of these as rails. This is going to be one side and this is the other side. So we're going to connect them on 2 separate sides. So now if we look back at the breadboard, I'm going to place it all the way over here, just so it's easy for us to reach. Now I'm going to take these 2 wires. The first one is going to go into our D13, which is the very last pin that we have on our board here. And if we look, and I'll provide this, if we look at the pinout, and this can be found at just searching for the nucleo-F303K8 board, we can see that our D13 pin is going to be for our LED 1. It's not anything very specific, it depends on how we write it, but this is going to be our part of our input. So we could plug this into here, and we're going to plug this into one of the columns for our button. So this is from D13 to one column of our button. Next, what we're going to have is power for it. And so the power is going to be with this 3v3, 3 volts. So we're going to take this red jumper wire that I have, we're going to put it in the 3v3, and then we're going to go to the other side of this button, which is right here. Now, we're going to want a pull down resistor to pull the voltage down to ground because there's too much of it. And so what we're going to do is we're going to take a 1 kilo ohm resistor. It doesn't have to be exact, but somewhere around that range. We're going to plug it into the side of the red, so the same column as the red, and then it's going to go into one of these rails. So from the red into here. Now that means we have to make this rail ground, right? So I'm going to take this little black resistor, or not resistor, but this little black wire, and I'm going to put it from ground. Fortunately, our nucleo-F32 has a ground, and it's going to be this second pin. So what I'm going to do is I'm going to take this, put it into the second column, and I'm going to put it into the negative row, which is where I'm going to be grounding the rest of these. So the resistor and that black wire are going to be in the same column. Now we can wire our LEDs. These are about 330 ohm resistors, and we are going to have these also to pull down to ground. Now I'm just going to place them in here randomly, not randomly, but it doesn't have to be in any specific order. It just has to be going from ground into a column on our breadboard. So that is 1. We're going to be using 3 LEDs, so we're going to do this 3 times. We have 1 here, we'll just place 1 over here, and then we will have a third one over here. Notice how they're all in the same negative column. That's because that's our ground, and they're all just terminating into different columns. And now we can put our LEDs. Now, when we do this, this voltage right here, the red wire, it's going to go into our button here. However, our button is an open circuit, so no current is going to flow through this blue wire. But from this red wire, if we push this down, obviously some of the voltage current is going to go this way because we have a pull-up resistor or pull-down resistor. And then we close this circuit, and with our closed circuit, the current is going to go into our blue wire. It's going to go back into the board with the D13, which when we code this, we're going to mark it as input. Now we have pins down here that we're going to mark as output, and they're going to go to our LEDs. So the current is going from this board to the LEDs, meaning that when we look at our LEDs here, we're going to be having the anode, which is the longer side, or the side that's perfectly round. The cathode has kind of like a bump right here. and it's going to be right here because the current is going to flow through it. So we can just connect these up. I'll put this one over here. So it'll just be in this column. Next, we're going to do a yellow one. We want these, we don't need them to be different colors specifically, but it is just easier to see. And then lastly, we have a red one, which I'm going to plug in here. And so with those all set, we can now put our pins in here. And that's it for the resistors that we're going to be using for this part. We'll be using the other three in our part 2. So we'll take these jumper wires and we're going to go from each of these individually. Now our green one is the farthest. I'm going to color code these. So I'm going to put this into the column of our D13. Same column as the D13 pin right there. And that's going to go into the green LED. Next, we're going to do the same thing for the yellow. We're going to move one column over, and that's going to go into the same column as our yellow LED. So it's going to look like this. And now we have this red wire. And we're going to take this, and we are going to plug it into the next column. And then we're going to go to the red LED. And that's it for our setup. Next, we're going to work on actually coding for the lights. And the code that we're going to write is just to have them light up when we press this button. And then after that, we're going to have a little bit of a delay, so there's a kind of a pattern in between them. If we were to plug this in right now, how it is, I have it set up to where it'll do that. So eventually, we're going to have it look like this, where there is a small delay. And it looks like a red one is not connected properly. So I'm going to shorten these leads, make sure that it is indeed in the correct column. I might have misplaced it, so I'll place it here and place it back in. And it does not light for some reason, so it could be that I might have short-circuited the LED earlier, but that's okay, because what I'm going to want to do is just replace it. So if there's a bad LED, you can always have kind of a test. You could just switch these two LEDs around, and if we do that, we would be able to see if it's working or not. So what I'm going to do is I'm going to take a brand new red LED. I'm going to place it in here, and I just realized it's not the LED that's the problem. So in fact, I'm going to place it back. The problem is, so now we're debugging it. The problem is not with the LED, it's with this. I put it in the wrong column, and I've only coded it for these last 3 columns. So I'll put it in here just like this, and now when I press it, it should have a small delay between each. So there's a slight delay in between all of them. We'll make the delay longer when we actually code this, and the next part is going to be coding for our board. Previously we looked at the breadboard, and now we're going to be looking at the code for this breadboard. Get rid of that. So the objective for this is to provide an understanding and rudimentary knowledge of basic I/O operations and development of microcontroller devices. So we have our components, and now we're going to look at this. So this is the software that we would be downloading. I already have it downloaded. It's the STM32 Cube IDE. That's what we're going to be using by Eclipse. So the general purpose of input-output. A GPIO, which is the general purpose input-output, is an uncommitted pin on a chip that can be configured into a digital input or output. This configuration process is set up by or during runtime with our compiled code. We have a basic structure of an I/O port bit, and it is right here. In the figure 7 above, we can observe the structure of our STM32 GPIO pin. There are 3 important built-in hardware to the structure of the STM32 GPIO. So the 3 importance is the pull up and pull down, the Schmidt trigger to help avoid input signal and contact bounce, and the NMOS and PMOS, which help to manage the pin states in push pull down mode and in an open drain mode. And we're not going to go over the terminology here. We're just looking at the actual lab itself. But that could probably be found easily by Googling it, which is good to know. We have an on-off, and we have our PMOS and NMOS. The STM32 I/O pins allow for 4 different types of modules: digital input, digital output, alternate, which allows the GPIO pin to be accessed by other peripherals such as UART, SPI, etc. And we have analog, I/O, which is input output. The voltage range can be seen in figure 9 below. We have these right here. Now we are actually going to look at some polling base in part B. But first, we have most times we represent digital I/O as a binary value. This is 1 or 0 for high or low. In reality, it exists in an analog world, so we abstract the voltage into just two levels, either high or low. For the STM32 board, the I/O pins are 3.3 volts, but it's important to note that most pins are 5 volt tolerant. On our STM32 board, to ensure that no damage to the microcontroller happens, we need to check if the pin is 5 volt tolerant before connecting a 5 volt input to it. Now we're going to follow the steps for our STM32 board. Polling base. So connecting the breadboard, I think we have done this previously, where we just have our LED, we have our resistor, we have ground. This was just what we did in the last video. Now we are going to be, so we'll skip over this since we've already done this. What we're going to be doing here now, I believe, is connecting more LEDs. So this is just looking over our part 1, which is the GPIO, where we only have one pin. And these are clock configurations and all the things that we have to do for this lab. Now, we are going to be copying this code. So this is very, very similar to what we done previously, but now we are just coding for it, right? So we're going to copy this and we're going to put it into our screen. And this is the rest of the lab here. We're not going to really look at it too much. We're just going to scroll through it and we're going to look at breakpoints and such like that. But we can just go through the actual STM32 Cube IDE. What is important though is that we have that code. We are going to come back for this code in a second, and then we need to have it actually light up our LEDs, which is going to have a delay in between. That's what the practical exercise is, the demo. So the demo is next. We're going to use the knowledge we gained in previous parts to make a simple program that when a button is pressed, 3 LEDs light up in a unique pattern. It should not just turn the 3 LEDs on and off when the button is released. So with that done, I can close this. I'm going to go into File. I'm going to click New, and we're going to do an STM32 project. Now, it might take a while to load. However, when it's finished loading, we can go up to our board selector, and then we can type in nucleo, and then we're going to do -F303, and we want the K8 for the specific board that we're using, and then we can click Next. From here, we're going to want our project name. It's going to be 2.1, just because of the 2.1. We can click Finish and then Yes to anything that comes up after this. And now we're going to load our actual project. So for our specific lab, we are going to be using the actual board that we have here to code for this. Looking at this and then going back here, we're going to want to declare inputs and our outputs. Remember that for our board, the input is going to be our D13. That's what we made it. So it's going to be tied with PB_3. It's going to be this one right here. We can left click it and we're going to want to do GPIO, and then we're going to do, well, previously for the last one, which I didn't show the code for it, but it's going to be very similar to this. We just make it an input. That would be the input, and then the rest are outputs. But it's going to be a exit 13 or EXT13, and that is so that we can have our exit for when we press it. Next, what we're going to want to do is have these 3 pins labeled, right? So we have our D12 tied with PB-4, and we know that's output because it's going to output the LED, so we're going to go to GPIO output. We have our PB5, which is tied with our D11, so we're going to make this output. Next, we have our PA11 tied with our D10. So we're going to find PA11, which is right here, and we're going to make it a GPIO output. We can go to, well, if we go to clock configuration, we can check out all this data that we have here. We're not going to touch it, but it's good to note. We have project manager, and we just have tools right here that we can look at, but we're not going to look at any of that. So we're going to look at our clock configure, or we're going to look at the pinout. We're going to go to system core. We're going to want to do GPIO. We can see that we have all this information right here that we can just look at. We're not going to look at anything specifically, but these are all the things that we have, and it highlights it here. What we are going to look at, if we move this over, is our NVIC. Now we want to have our EXT1 line 3 interrupt checked, so we can click that, and it is now enabled. With that enabled and everything selected, we can go and build our project. So we're going to go to project, and we're going to do build project, and it should build our project from here. Once that runs, what we should do is, I believe we can control save, and we want to generate code. If it doesn't come up for some reason, you can control save. We'll click yes to this, and then we're going to click yes to our open perspective. Sometimes this IDE can be a little bit finicky. And then this is the code that we're going to look at. So we have all of these, and we'll go over them a little bit in the next video, linked in the playlist below the like button. But for this specific code, what we're going to want to look at is what we had previously. So if we look in our lab document at the code I copied, it's very important. We can see right here. Underneath user code begin 3, we can take this and we're going to paste it in. And then it's above user code end 3. So between the begin and end. And this is important because if we paste it in between the begin and our end for the code, what we're going to have is this code stay here whenever we rebuild our project, so it won't overwrite this code. If it's out of these end and begins, we would actually have our code be overwritten, and we might not want that. So it's going to have right there. Now there is one more thing that we have to copy for this project, so we can scroll down until we find it, and it's going to be, should be right here. Right here we have this, and it's not going to be in the same file. It's going to be in our STM32F303 file. So for this file, we can go into our core again. We can go to src, and we're going to look for it. Remember, it ends in the xx_it.c. So what we can do is we are going to double click this, and this will come up. Now we can scroll down a little bit and we are able to find it. Or what we can do is just copy this right here, do a Control F, and find it. And we have it right here. And it should be the only one. We have these two right here. And looking at this, we can see that we're going to want this code to be right above it, and then we have this 1 right here. So the difference was that this has 0 and this has a 1, and we want it underneath the 0. So it's going to go right here, and it's going to toggle the state of our pin PC9. So we can control save this. Now we're going to go back to our main and actually code. So in this code, in our while loop, wherever we have it, what we're going to want to do is change things inside of here. We have this if statement, and this if statement is saying that, well, if our pin is red, the GPIO at B and the GPIO pin 3, this is going to happen, everything inside of it, which is this currently. We are going to write to this pin, which is the GPIO B, and then we have the GPIO pin 4, and then the pin set. So we are just setting a pin here. Now, if we want to delay, notice how we have this delay right here, HAL_delay. So we know we want to do this twice, so we can take these delays and paste it here. I'm just going to make the delay 200 like this. Now, after this, what I'm going to want is some more code in here. It's going to be slightly different, but we can copy this in here. What we're going to want to do is change the actual kind of address that this is at. Notice we have GPIO-B, and if we look at this, we are going to want to change from B to A when we're dealing with the 11. How do we know which one's which? Well, if we look at this, we have pin 4 for this first one, and we can see that it is PB_4, right? So we have B and then pin 4. It's kind of how that works. So this next one, we want to light 5, right? This is the next one we have in our order. So it's going to be 511. So we can change this from 4 to a 5. So 4 to 5. And then this is still going to be a PB. So this GPIO-B can stay the same. Now we can copy this and we're going to paste it down here. Now we have the GPIO. If we notice now with pin A, or PA11, we have an A. So instead of B, we're going to take this off and have an A. GPIO pin 5 is going to change from pin 5 to our pin 11 because we have an 11 here. So we will backspace this, write an 11 here, and we are setting these. Now we're going to want to reset these once our button is released, right? So we're going to want to copy this and change it from set to reset because it resets it to 0. Remember that we either have 0 or 1, which is on or off. And I'm going to keep the delays in just for an interesting output. And we're just going to change this to reset and this to reset as well. From here, we can save this, control save. We're going to go to project. We can go to build project. I don't know if that's exactly necessary, but what we will do is run our debug. So we'll click debug. And I think we have to, we have to select an option for it. So we're going to do run. We'll do debug configurations first. We'll do 2.2.debug. I don't know if that was a good idea. So instead of doing that, let's do debug configurations. And this should be fine. We'll try this out. We'll do switch, and this is going to load our debug here. I believe it's just using the same thing, and we can check if this works or not. So the download was successful. I have my board plugged in, and it should be running it. Now it hit this breakpoint right here, HALINIT, where it resets all our peripherals. So to continue this, we can just press this continue button. And now it actually did run the previous code. And we don't want that. So what we're going to do is we're going to stop this. We don't want to run our 2.2. We can see that it ran our 2.2. So that's good to know. We're going to go into run. We'll go do debug configurations. We don't want to run our 2.2. So let's change this, right? I didn't have it over all the way, so all I saw was a 2.2. We're going to double click this STM32 Cortex like this, and it's going to make a file like this. We don't want the project 2.2. We want 2.1. It says that project does not exist. It says 2.1. So we can search projects down here. We can click OK to this. And we see that it is because it was clicking the wrong thing. So we want our application to be selected to the 2.1, what we're doing here. And our project is going to be the 2.1. We'll click run from here, and this should run it correctly. Now, what I'm going to do is after this runs, we're going to wait for a debug menu, and I'm going to open the camera back to the breadboard, and it says that we are shutting down and we've exited. So what we can do is we can go back and run this. We don't need to always run with the debug. It's not 100% necessary, but we're waiting for a debug connection. Debug has connected, we've downloaded, and we are shutting down. So I'm not 100% sure why that is. We can click run again and try to run it. Might be a problem with the code. So what we're going to do is we're going to go to project and we're going to go to clean. Now we want to clean all projects, so we can click clean all projects and click clean. Should clean everything up. And now what we're going to want to do is we're going to go to project. We'll go to build project, and it should build our 2.1 that we have here. Now we're going to go to run. We'll go debug configurations. We want to run our 2.1. So the name of this should be the 2.1 debug. So we'll change this just so our name is okay. We're running the 2.1 project and the 2.1 C++ application. We'll click apply, and then it should load, and we can click debug from here. From this, it's going to load our build, wait for the debug connection, and now we want to switch our perspective. So whenever something doesn't work, great way to first start is to clean our project. We'll click switch from here so we can switch into the debug menu. Just to test it, we can go up here to click resume our program because it has a breakpoint right here. We can see that if I press the button, it has a delay, and then it has a delay when it turns off. So that's pretty cool. It has a longer delay than what we had at the beginning of the lab, and that's because I just programmed it with a longer delay. I have to hold this button and they all light up. Now if I let go, they all light down, and if I were to let go in between, it would still carry the signal. So all I would need to do is press it once and it would go. It needs to register a little bit though. And so that's it for this lab, and that is the code that we've written for it.